All right, so today is November 1st, which means it's the first day of No Shave November. So if you want to participate, you can start fresh today, maybe shave tonight, but rest of the month, let it grow. So as you can see, I'm starting fresh, shaved last night. That way I can get the full effect just for this month. So we got some math to do. I know we're not here to talk about beards all day, but you just got to see that I'm starting fresh. So fresh, so clean. So fresh, so clean. So you should have this sheet. Let's talk about the side angle triangle inequality, and then we're going to do some practice on the back. And then I got an assignment for you. Please do make sure that you've done all 4 assignments so far. Classifying triangles from 1025, triangle sum theorem from 1026, classifying uses distance formula from 1029, and triangle inequality practice from 1030. Okay. Yesterday we took a quiz. It was a great trick, and here we are moving on. So this tells us to put the angles in order from the greatest to the least. Okay. All right. So the angles. Let's look at our angles. We got 74. We got 58. So 74 is my greatest angle. We're going to put the angle name, angle B. We're not putting the measurement. We're not putting 74. Then our next greatest, our middle one, is going to be 58 degrees. So that's angle A. And then our least angle, angle 48, which is angle C. All right. And we're also going to put the sides in order from greatest to least. So, which side is the greatest? 18. So AC is my greatest side, greatest measurement. And then the next one we have is BC for 15. And then the least is 13, AB. Okay, so the question we have here, what do you notice about the relationship between the greatest angle and the greatest side? Okay, so our greatest angle is angle B right here, which is in relationship. Where is angle B in relationship to side AC? What do you notice? Let's think about it also for angle A and BC. We got angle A right here, and then side BC right here. What's the relationship? We also have angle C right here, and side AB over here. And then what's their relationship? So each of these, from greatest to least, have a relationship in that they are across from each other. The greatest angle is across from the greatest side. The least angle, the least in its measurement, the angle is across from the least in its measurement side. So we want to be able to write a conjecture so we can be able to put these sides and angles in order. So the longest side of a triangle is try to make that small. Make sure you get this down. The longest side of a triangle is across from the longest angle, and the smallest side is across from the smallest angle. This is going to help us on the practice when we need to put sides and angles in order when we have missing side lengths or missing angles. We can figure it out by the relationship to what they are across from. Down at the bottom for the Isosceles Theorem, we talked about this when we learned isosceles, and now we're going to apply it. But you can write this up here at the top of the bottom section. The two angles across from the two congruent sides are also congruent. It also works vice versa. And that's a fancy phrase. That just means it works both ways. So if you have two congruent sides, the two angles across from those two congruent sides are also congruent. That was in the definition of what it means to be isosceles, and we are going to apply that here. And then also, we'll talk about it on the practice on the back of this. So, let's look at these examples. We have this first triangle. It's actually not merely isosceles. It is also equilateral, but it does have two congruent sides in it. So, let's talk about this. If these three sides are congruent, then each angle has to be congruent. So if this one's 60, which it has to be for an equilateral, then this one has to be 60, and then of course this one has to be 60. So that one was actually just for an equilateral triangle. Hopefully that one wasn't too hard. Okay. This next one, okay. We know the triangle sum theorem that the angles inside of a triangle have to add up to 180 degrees. And we were able to do that on the quiz yesterday and the assignment from last week. But what if we're missing an angle, right? This angle, we don't know what it is yet. However, hopefully you notice it's an isosceles triangle. So if across from this tick mark is 69, then across from this tick mark will also be 69, because that's the isosceles triangle theorem. That's what we know about the two congruent sides, is that the opposite angle, two angles are also congruent. So now we can do this triangle sum theorem. 69 plus 69 plus x equals 180. 69 plus 69 is 138. And then we can subtract 138 and get 42 degrees. All right. This next one's super easy. These arcs, remember, mean congruent angles. So across from this arc is 6 as a measurement for that segment, that side length. So across from this arc is also going to be the same thing. Two congruent angles gives us two congruent sides. So this x has to equal 6, because we know it's isosceles. Okay. Now this is a trickier one. So I see two tick marks. So if this is 75, then this is also 75. Now this is not 2 degrees. You got to look up here. Measure of angle 2, this right here is actually 4x plus 14. Okay? So we have 3 angles, 4x plus 14, 75, and 75. So let's set this up. 4x plus 14 plus 75 plus 75 equals 180. We need to add up all of our like terms. So we add them up, we should get 164. We get rid of our loner by doing the opposite, the inverse operation. So 4x equals 16 once we subtract, and we divide by 4, and x equals 4. Okay? So those were just some samples of what we do when we have an isosceles triangle. When we have a missing angle or a missing side, we look for congruent angles or sides, respectively, across from that. So let's go to the practice. All right, so on the back side here, it asks us to order the sides. Okay. Every year, this gives people trouble, okay? I'm not asking you for angles, I'm asking you for sides, okay? So sides are either going to be FE or EG or GF, okay? So let's do this. Also, you got to be very aware, because I'm not always asking you the same thing. This time I want it from shortest to longest. So if I want the shortest side, I'm going to first find the smallest angle. So does everyone see my smallest angle right here is 30. So now I got to think, across from 30 is what side? Sides always have 2 endpoints that we label it with, the notation that we learned in week 1. So again, angle E is across from segment FG. Let's write that down. That's my smallest side. I know that because it's across from the smallest angle. All right, and comma. Let's do our next one. What's the middle angle? 32. 32 is across from GE. And the longest side is across from the biggest angle, so 118 is across from FE. Okay? I'm telling you, most people, when they get this wrong, it's because they put them in angle order. They'll tell me E and then F and then G. Okay? Those are angles. That's not what I'm looking for. So please read these carefully. On number 2, it says order the angles from smallest to largest. So if we want angles, first we got to look at these sides. Which side is the smallest? ST. ST is across from angle R. So angle R, comma, the middle side is 9. 9 is across from angle T, comma, and the longest side, 12, is across from angle S. Do you see how the angles match my answer? Sides match my answer on number 1. Please be careful. Number 3, order the sides of each triangle. So again, sides from shortest to longest. So the smallest angle is across from WU. The middle angle is across from VW. And the biggest angle is across from VU. Okay, so sides, shortest to longest. And let's do these real quick. If I got an equilateral triangle, then you know this angle has to be 60. But also, you know, every side is equal, so every angle is equal, so everything needs to match. So that's going to be 60. Okay, congruent angle, so x has to equal 12. Okay, congruent side, so if that's 46 across from this one, then that across from this one needs to also be 46. Angle 2 goes right there, right? That's what it says right here, angle 2. So we got to set that up. 11x plus 11 plus 46 plus 46 equals, in a triangle, 180. Combine like terms. $103. Okay, so bring down 11x. Let's subtract 103. 11x equals 77. And then all we got to do is divide by 11. And we get 7. So those are the types of problems you'll see today. You'll have to order sides and angles today, and you'll also have to find missing values solving for x, given what you know about isosceles triangles.